Hi, logic students. I wanted to make a recording on section 6.5, the one where we do the indirect truth tables. I just wanted to demonstrate how to do those, and it seems to me that the process is overall pretty straightforward, although you have to keep some things straight, so I'll try to emphasize them. I just wanted to show you basically a simple exercise here. It's an indirect method for doing truth tables, which means that instead of doing the whole truth table, you just assume that the argument is invalid. So you will assume that once you've written down the argument premise separated by a slash from the next premise and then two slashes to separate the conclusion. Once you've written down the statement, the argument as a whole, you will assume that there is a line in this argument where all the premises are true and the conclusion is false. So you will assume that it's invalid. You will assume that there is a line where the first premise is true, where the second premise is true, and where the conclusion is false. And once you've made that assumption, you see where that takes you. You keep working on the basis of that assumption and see if you can make a consistent assignment of truth values to all the letters and all the logical operators based on that first assumption. So this is a simple argument, so it works out immediately because the first assumption is to make the premises true and the conclusion false. So basically you're assuming the conclusion P to be false. So you have to report this under the other P as well. And you're assuming Q to be true. So you have to report it under Q. And then you process the negations because you assumed Q to be true, not Q has to be false. And because you assumed P to be false, not Q. Not P has to be true. Okay, so you've made all the assignments and then you check to see if there are any inconsistencies or violations of the laws of logic, and it seems like there's no problem. This is assumed true, and it has a false antecedent, a true consequent. So there's no violation of the rules for the truth table for the conditional. So it's possible for this argument to have all true premises and a false conclusion when Q is true and P is false. So this would be a line in the truth table. If you were to do the complete truth table for this argument, obviously there would be a line where Q is true and P is false, and this would be the line that proves that the argument is invalid. So invalid is your decision here. If you try to do this with a valid argument, you can't do it. Because if you take a valid argument like this one and you assume that there's a line in its truth table where all the premises are true and the conclusion is false, you just can't do this because that line does not exist. The argument is valid. So there is no line in its truth table where all the premises are true and the conclusion is false. If you try to do it, you will inevitably contradict the rules of logic. So let's follow the consequences of this assumption. Let's assume the premise to be true and the conclusion false. If not A is to be false, A must be true. And if not B is to be true, B must be false. See what happens? You've made all the assignments, but there's a contradiction here. This first premise was supposed to be true, and with a true antecedent and a false consequent, it's actually false. So you just cannot assign, or you just cannot make all the premises true and the conclusion false in a valid argument. If you try to do that, a contradiction pops out. And so you know, because of the popping out of the contradiction, that the argument is valid. Okay, let's try to do this with a slightly longer and more complex argument. This is number 7 in part 2 of exercise 6.5. And you always handle these in the same way. you line up the argument like this, all the premises separated by slashes, and then a double slash for the conclusion. And then you start by placing a T under the main logical operator in all the premises, and an F under the conclusion or the main logical operator in the conclusion. And then you get some clues from this that will allow you to complete all the assignments. So in this first round of assignments, you made J false. So you have to find all the J's and put an F under those. There's only another one here in the third premise. And then the first assignment was also that not I was to be true, so I has to be false. So I has to be false here. And this assignment of false to J immediately allows you to figure out that not J must be true. Okay, so you may ask, well, where do I go from here? What do I do now? Well, simply you just follow the assumptions that you've made and see where they lead you. Okay, keeping in mind that you're trying to make all the premises true and the conclusion false. So for example, here in the third premise, we're assuming that if not J, then G, the third premise, must be true. And we just found that the antecedent, not J, is true. So if you want to keep the whole third premise true, then it better be the case that G is true. So we have to make G true. We're forced to make G true, because if we made it false, this would be a conditional with a true antecedent and a false consequent, so it would go from true to false. So G has to be true. And over here, of course, we do the same thing. We want if G then H to be true. So if G is true, H cannot be false. Otherwise, if we put false under H, the whole conditional will turn out to be false, not true. So H has to be true. So we put it here as well. So we've made assignments for all letters and operators. Now we have to check to see that there are no contradictions, no violations of the rules of logic. And immediately, I think you can see that there's a problem here. I had to make I false, and I had to make H true, but then with a true antecedent and a false consequent, if H then I cannot be true. There's a contradiction here. So we were trying to do something that is impossible. There is no line in the truth table for this argument that has all true premises and a false conclusion, so that means that it's a valid argument. Okay, so I think that this should clarify how to work with these exercises. I just wanted to emphasize that this is just one type of exercise where you can do the indirect truth table. There's also another type. If you look at section 6.5, so this exercise was from part 2, was number 7. So here the task is you have an argument, and the question is this a valid or invalid argument? So that's how you use the indirect truth table to find out if it's valid or invalid. But in part 3, you don't get arguments. These are not arguments. They're simply sets of statements, and your task is slightly different. You don't evaluate them for validity or invalidity because they're not arguments. Your task is to determine whether these statements are consistent with each other, so if they can all be true together. So what you're going to do, if you look at the solution for this one, what you're going to do is you're going to assume that they're all true. The first, you're going to assume true. The second, you're going to assume true. And the third, you're going to assume to be true. And then you see if you can find values for the letters that make all the statements true at the same time. If you can do it, then the statements are consistent with each other. If you try to do it and a contradiction pops out, that means, as in this case, that these statements are inconsistent with each other. They cannot all be true at the same time. So keep in mind that the task in part 3 is different from the task in part 2 in this exercise 6.5. Let me know if you have any questions. Thanks.